I am Anil Kumar. Welcome to my series on numerical solutions of equations. I have taken up a question, part of it, from one of the test papers of Cambridge International Examination. Let me show you the question in the examination paper, which we will also solve. Here is this question number 5, right? So it is the same equation on which we are going to work. After providing you solution of this equation, we'll discuss the test paper, which I have taken from level 3 GCE Mathematics, Advanced Mathematics. Okay, so let's first discuss how do we find solution of an equation using Newton-Raphson method. So the question here is, the equation 2x cubed plus x squared minus 1 equals to 0 has exactly one real root. Find its solution accurate to 2 decimal places using Newton-Raphson method. Now, what we can do here is that we can check the value for the function, which is 2x cubed plus x squared minus 1 equals to, let's say this is our function f of x, right? So we'll consider this to be our function. Now we are saying solution, that means equal to 0, correct? So the value of this function at 0 basically is minus 1, and the value of this function at, if I substitute here 1, then we get what? We get 2 plus 1, 3, minus 1, which is plus 2. So we get 2. Now since the function becomes from negative to positive, that really means that we expect a real root in this interval, right? From 0 to 1, correct? Within this interval, we expect a root. As far as the Newton-Raphson method is concerned, it is a very efficient method where we can find the roots using the formula. I'm not going to derive the formula. However, I'll provide you with the formula. The formula is that we will try the values x. It is an iterative process, right? So you have to start with some value, which we are saying xn, and then xn minus the value of function at xn divided by its derivative at xn provides that the next value to try, correct? So that is the way of finding different numbers to try. Now using this formula, we need to find the value of the function and its derivative. The function, as I said, is equal to 2x cubed plus x squared minus 1. Its derivative is 6x squared plus 2x, correct? So that becomes the derivative. Now, using this formula, we can say that xn plus 1 is basically equal to xn minus, the numerator will be 2x cubed plus x squared minus 1 divided by 6x squared plus 2x. Now since we know that the root is between 0 and 1, we can actually start with 1. Why are we not starting with 0? That's important to understand, really, because at 0, the denominator is going to be undefined. Denominator is going to be 0, so that is undefined, correct? So the derivative is 0 at 0, so we cannot use 0, right? So we will start with 1 and approach towards 0. Okay, so we'll start with xn equals to 1, right? So that becomes our starting point. As you can clearly see that we cannot, let me write down in a different ink here. We have f dash 0 is equal to 0. Therefore, this method cannot be used for x n equals to 0. Clear? Because that will become 0. Perfect. So we are not starting with 0. We are starting with 1. So I hope that part is clear. So let's calculate. So first value, we are saying x1 equals to 1. Correct? So what is x2 equals to? So x2 will be x1, which is 1, minus, we get here 2 plus 1 minus 1 over, we'll substitute 1 here. So we get 6 plus 2, right? So that gives us the first value. Now once we get this value, we'll try the third, fourth values also. But we should actually do this calculation with the help of scientific calculator, since it is much faster. So I'll show you how to also evaluate these numbers using scientific calculator. So xn is 1, so we'll write 1 minus, then we have to use this term, so I'm going to put everything in brackets, correct? So I'll put 2 brackets here. So in the first bracket, we'll put the numerator, which is 2 times 1 is our first value. We'll cube this, correct? We'll cube this, plus we have 1, we'll square that one, minus 1, correct? Bracket close, divided by the denominator, which is 6. 1 will be squared, and then we have plus 2 times 1, correct? And 2 brackets closed. And that gives you the value as, we get 3 over 4, right? So we get one value, which is 3 over 4. Now 3 over 4 is in our answer, right? So 3 over 4 is in our answer. So we are going to use this answer to calculate the next number, which is x3. So basically for x3, that becomes your x2, right? So the formula will be, here we have 3 over 4 minus, so in this formula we have now 2, 3 over 4 whole cube plus 3 over 4 square minus 1 over 6 times 3 over 4 square plus 2 times 3 over 4. Clear? So instead of 3 over 4, we'll write this as answer. So we'll write answer, which is 3 over 4, right? Minus, again 2 brackets. So the numerator is 2 times the answer cube, right? So we can write answer cube plus answer square minus 1, right? So it becomes very convenient, bracket close. Now we'll divide, open a bracket for denominator, 6 times answer square plus 2 times the answer, and then bracket close equals 2. So we get this as 2 over 3. Correct? So we have x3 as 2 over 3. Let's find what is x4. So for x4, 2 over 3 becomes x3, right? So we get this as 2 over 3 minus 2 times 2 over 3 whole cube plus 2 over 3 whole square minus 1 over 6 times 2 over 3 square plus 2 times 2 over 3. Is that clear to you, right? So let's recalculate. So we have this answer minus, now this part, which is 2 brackets, 2 times answer cube plus we have answer square minus 1 bracket close divided by bracket open 6 times answer square plus 2 times answer bracket close equals to. So we get this as 71 over 108. Let's also convert to decimals to see what numbers we are getting to, right? 0.65740 recurring rate. That's what we got. Now let's try the next value, which is x5. So x5 will be this number, right? So which is whatever we have. Let's do this calculation. I'm not writing here now. So we get the answer minus 2 brackets 2 times answer cube plus answer square minus 1 bracket close divided by bracket open 6 times answer square plus 2 times answer bracket close equals to. So we get now a value which is 0.65729, right? So still the third place is matching, right? 0.65729. We can go further and calculate sixth value. So that could be, again we'll put the answer back, right? Minus 2 brackets, and we have 2 times the answer cube plus answer square minus 1 bracket close divided by 6 times answer square plus 2 times answer bracket close equals to some error. Let's see what happened. Okay, so we didn't put a bracket here. Okay, let me put the bracket here. I think that should be fine. So we get our answer as 0.65729, right? So 729 is matching. So now we do have fairly good answer to 2 decimal places. That is what was required, right? So accurate to 2 decimal places. We have our answer here. So our solution is x is equals to 0.65. Is that clear to you, right? So I hope you understand how to apply this method. The formula is given here. No proof is being given at present. Now use this formula. I also shown you how to use your calculator to really calculate it much faster. Iterative process. So put back the answer and get your solution, correct? That's the whole idea, and that's how it is. You can actually also calculate or check your answer, right? So let us check. We have our answer here. So we'll put this answer in the equation to check, right? So let's perform a check. So what I'm doing is, I'm doing 2 times, let me write here, times answer cube. I'm just substituting answer here, right? To see how accurate we are, plus the answer square minus 1 is equal to what? See, it gives you 0. So it's actually that particular answer which we got right here is a very good answer, right? Whatever this number was. So the check pass. So that is how we could actually also provide fairly accurate answer, solution to any equation using Newton-Raphson method, right? Now let's take the test problem and see how to solve that test question. So now let us solve this test question, which is the equation 2x cubed plus x squared minus 1 equals to 0 has exactly one real root. Show that for this equation, the Newton-Raphson formula can be written as xn plus 1 equals to 4xn cubed plus xn squared plus 1 divided by 6xn squared plus 2xn. Using the formula given in part A with x1 equals to 1, find the values of x2 and x3. Explain why for this equation the Newton-Raphson method cannot be used with x1 equals to 0. So that means you cannot start with 0, right? Okay. So the base was already provided you in the first part. Now let's really answer these questions. The Newton-Raphson method gives you the formula for xn plus 1 as xn plus the value of the function at xn divided by its derivative, right? That's the formula, correct? Now, let's find, we are given the function, let's find the derivative. So function f of x is equal to 2x cubed plus x squared minus 1. The derivative of this function is 6x plus 2, 6x squared plus 2x, correct? So using this formula, we can say xn plus 1 is equal to xn, and substituting xn in the function, we get plus, and here so it is not plus but minus, right? Yeah. So substituting xn here, we get xn minus this value, which is 2 times xn cubed plus xn squared minus 1 divided by the derivative 6xn squared plus 2xn. Okay. Now we can take the common denominator, which is 6xn squared plus 2xn. So we got the denominator right, and we are going to multiply this with this. So we get 6 times 1, which is 6xn cubed, right, plus 2xn squared minus, we have here 2xn cubed minus, that is also minus xn squared plus 1, correct? So combining the like terms, 6 minus 2 is 4, so we get 4xn cubed. As far as the square terms are concerned, 2xn squared minus xn squared is 1, so we get xn squared, and we have plus 1 here divided by 6xn squared plus 2xn. Clear? So we have exactly what was required. Is that clear? Right? Now, using the formula given in part A, which is this formula, with x1 equals to 1, find the value of x2 and x3. So let's do that. So let me just push the page a bit. So that's the formula which we are going to use. We say x1 is given to us as 1. So x2 is going to be, we'll place 1 here. So we get 4 times 1 plus 1 square, this is cube, plus 1 divided by 6 times 1 square plus 2 times 1, which is 4 plus 1 over 6 plus 2, that is 6 over 8, or is 3 over 4, correct? So we got x2. Now let's calculate x3. So for x3, we'll substitute 3 over 4 here. Now we did this calculation, right? So they are exactly the same values. So we have 4 times 3 over 4 whole cube plus 3 over 4 whole square plus 1 divided by 6 times 3 over 4 square plus 2 times 3 over 4. Let's use calculator to find this answer. Let's use calculator to find this answer. So what I will do here is that I'll do 3 divided by 4, and that is 3 over 4 in my answer now, right? So I'll use this answer to calculate. So in the numerator, let me put bracket here, 2 brackets to begin with. First we'll write numerator, divide by denominator. So we have 4 times answer cube plus answer square plus 1, bracket close, divided by the denominator, which is 6 times answer square plus 2 times answer, brackets close, and that gives you 2 over 3. Clear? So this technique is very good to calculate. So I hope if you use your scientific calculator wisely, you can actually figure out the answers very fast. So we got both the answers. So we have x2 as equal to 3 over 4 and x3 as 2 over 3, right? They match with our previous answers, correct? Part C is explain why for this equation the Newton's Raphson method cannot be used for x1 equals to 0, right? It's a very good question. You cannot start with, we start with the initial value of x1 equals to 1. We cannot start with 0. You know why? Simply because, so let's see, let's write down answer C right here. For C, f dash of 0 is what? So the derivative was 6n square, right? So f dash of this is 0, right? So that in this method we cannot use x1 as 0 since the derivative of the function at 0 is 0. You cannot divide by 0, right? So that is a restriction. So whenever you use this formula, so in this formula it is important to understand that the derivative at your given value is not equal to 0. Clear? That is very clear. So at 0, it is 0. Therefore, we cannot use that value. Is that clear to you? So I hope all these steps are absolutely clear. You have seen how to answer this question, which we picked up from this international test paper. In case you have any doubts, you can always send me an email on the address given here. Feel free to share my videos. If you like and subscribe to them, that'd be excellent. Thanks for watching and all the best.